Hello guys, this is part 2 of thermochemistry. If you haven't watched part 1, which is on energy and heat, the link is in the description box below, but this video is going to be on the calorimeter and calculations. So what is the calorimeter? An interesting fact about the calorimeter is that scientists use things called bomb calorimeters to measure the nutritional facts, like the calories on nutrition labels, using combustion reactions which are carried out in these calorimeters. But for this purpose, the purpose of this video, the calorimeter is an insulated device used for measuring the amount of heat absorbed or released during a chemical or physical process. And we are going to be specifically focusing on foam cup calorimeters, which are open to the atmosphere. They have constant pressure, but is an insulated chamber with a known mass of water in the chamber, which is used to absorb the energy released from the reacting system or to provide the energy absorbed by the system. And it can be used to determine the specific heat of an unknown metal, which we are going to do in this video. So how do you determine the specific heat of an unknown metal? So here's a scenario. Suppose you put 125 grams of water in a foam cup calorimeter and find its initial temperature, and you have a known mass of metal, and you heat it to a certain temperature and then put the metal sample in the water. So what happens is when you put the heated metal in the water in the calorimeter, the heat flows from the hot metal to the cool water. As you can see, the T2 is hotter than T1, so it flows to the water, and the temperature of the water goes up. And then when the temperature of the metal and the temperature of the water are at the same temperature, the transfer of heat stops. Here is a more visual, and it's an experimental procedure which is taken from the chemistry textbook. And so first here we have a foam cup calorimeter. As you can see, there is a thermometer sticking out of the foam cup calorimeter. And the first thing that we do is we record the initial temperature of the known amount of water, which is already in the calorimeter. And secondly, we heat a metal in a separate container of a known mass, a metal of known mass, and then after we heat the metal, we place it in the calorimeter where the water already is. And then what happens is the metal transfers heat to the water, and it transfers heat until they're both at the same temperature, and then you record the final temperature. So we're going to go back to this example scenario, and we are actually going to calculate the specific heat of this unknown metal. So suppose you put 125 grams of water in a foam cup calorimeter and find that its initial temperature is 25.6 degrees Celsius. Then you heat a 50-gram sample of the unknown metal to 115 degrees Celsius and put this metal sample into the water. The metal transfers heat to the water until the metal and the water are at the same temperature. The final temperature is 29.3 degrees Celsius. And this follows the experimental procedure that I was just talking about. So the first step that we're going to do is we're going to calculate the heat gained by water. And in order to do this, we're going to use the equation Q equals mCT. And we are given, so in order to calculate the heat, which is the Q here, we have to know the mass. What is the mass? The mass of the water is 125 grams. And the specific heat of water, well, it's not given here, but it is widely known, and it's 4.184 joules, multiplied by the change in temperature. The change in temperature is the final temperature, 29.3 degrees Celsius, minus the initial temperature, 25.6, and we're going to put this in our calculator here. Just calculate 125 times 4.184 times 29.3 minus 25.6. Oops, I did something wrong. 125 times 4.184 times 29.3 minus 25.6. And we get the heat absorbed or gained by the water is 1,935.1 joules. Now, the heat absorbed by the water is transferred from the metal. So basically, the heat absorbed by the water is equal to the heat lost by the metal. is equal to the heat lost by the metal. Q of gained by water is, and because it is lost by the metal, we have for the metal, it's a negative 1935.1 joules. So that now that we know the heat lost by the metal, we can calculate and solve for the specific heat of the metal. So we'll use the equation Q equals mCT to calculate the specific heat. And first we know the mass of the metal in this example problem is 50 grams. So we can put 50, 50 grams multiplied by the unknown specific heat. Why did it do that? And the change in temperature, well, the change in temperature here, first we know that the initial temperature is 115 degrees and the final temperature is 29.3. Remember that the change in temperature is the final temperature minus the initial temperature. So 29.3 minus 115 degrees Celsius. And since these are both negative, when we put them in our calculator, our specific heat will come out to be positive. Sorry, this is taking quite a long time. Divided by 50 times, and we get a specific heat of 0.452, and the units are joules per gram degrees Celsius. So what is this metal? Given the specific heat of this metal, we can use a specific heat table that can be found in the textbook, or you can just search it up online. But this specific metal is iron, Fe. And for calculations, you are not always going to be calculating specific heat, and you're not always going to be given a calorimeter problem, but you can basically use Q equals mCT. If you know 3 of the 4 variables, you can solve for the 4th variable. And that is it for this video. Thank you so much for watching, and I will have more videos on thermochemistry uploaded. And if you haven't watched my part 1 thermochemistry video on energy and heat, again, it is linked in the description box below. I hope you guys found this video to be helpful.